Welcome to the Sophistic Bridge Design SOFinar part 4 of 6. My name is Matthias Singh, and today we're defining the traffic load for our frame bridge, and for that we are using the live load analysis task, which you can find in our library task in SSD. So in today's SOFinar the focus will be just on the Eurocode, but there are also just other design codes available like AASHTO or British Standard. And we are looking for the envelope of the minimum and maximum forces and moments of the traffic load. So that means the search for the most unfavorable load position for every single element. And there are two principal approaches available in Sophistic to find the most unfavorable load position. So you can select between the load stepping method or the influence lines. And if you choose the load stepping method, we just have to generate, we can generate a number of representative load cases explicitly, and each load case contains the load model at distinct positions along the axis. The load cases are then calculated and the envelope is obtained with the superposition module of maxima. And if we choose the second method, so the influence lines, we just have to establish at first influence lines for forces and moments of all the selected locations within the structure. And in the second step, the influence lines are evaluated with the modular LR by applying the load models. The envelopes of the results can be directly obtained from this evaluation. And please note that this procedure will be used by the live load analysis task. That's what we're going to use today for defining the traffic load for our frame bridge. But before we will start, just a little explanation again for the GoToMeeting software for everyone who never used it before. So you will find a button to display full screen, and you can type your questions into the box which you may have during the SOFinar. If you won't get the answer during the SOFinar, you will get it afterwards as soon as possible by email. So before we can use the live load analysis task, which is also called traffic loader task, we just have to define at first the actions in SOFI+. So we're switching to SOFI+. And in the tab loads, you will find the load case manager, and there we just have the tab actions, and there you can just create new actions. So according to the Eurocode, already just defined the actions, so we just have the action for the horizontal loads, for the pedestrian walk areas, and for the Tandem system and the UDL. And these actions are just like containers for each of the load groups we just have to define later on. We have to take different action types because of the different coefficients for the different load groups, which are just defined in the Eurocode. So you can see that we just also have different types of superpositions. So we just have the extended exclusive superposition and also the exclusive superposition. So what are just the difference? So for the uniformly distributed load and also for the tandem system action, we're just going to take the exclusive superposition. So for each of this container, we will just get the most unfavorable load case. And these load cases will be just taken into account. And for the horizontal loads and the pedestrian walk areas or loads, we're just going to use the extended exclusive superposition. So that means that only the most unfavorable load case will be taken into account from the action group horizontal loads or pedestrian walk, but only if the load case will be just have an unfavorable contribution. Okay. If we want to use the live load analysis task, what we're just going to do today, we necessarily have to define before an axis in SOFI+. That's what I just showed you in the first SOFinar. So the traffic load will be just based on the axis. So we are also using the advantage of the CABD technology so that in case of changes of the bridge we don't have to redefine the traffic load, because they will automatically change according to the change of the geometric parameters of the axis. And then we're just making an export to SSD. And I just defined the load case for self-weight and also a load case for the pre-stressing of the tendons. And we have to calculate at least one load case if we want to use the live load analysis task, so that we will have a stiffness matrix. And just be careful which construction stage you're going to use for the traffic loading. And we are using the final stage of our frame bridge. But of course you just have also the possibility to use just different stages. And that's why I just have to calculate it first, our text editor task, which I just showed you in the last SOFinar. And then as you can see it here, I already just defined a group, which you can do with a right click in the task tree. And then we're just inserting a new task, which is called the traffic loader task, or the live load analysis task. And with a double click on it, we can just open it, and then you can see that we just have 5 tabs to define the traffic load, what we're just going to do together. So now we're just in the first tab, the lanes, and here we can just define the lanes, which is just based on the axis. And so you would just find it first and drop down menu with all the defined axes in SOFi Plus, and we're just taking the main axis AX_1. Then we just have here our section drop down menu, and there we just have a different automatic subdivisions according to the specific design code. So we're just taking the Euro code, and then you can see that we just have a default of 3 lanes in the graphic above. So why do we have 3 lanes? So we just switch back to PowerPoint. I would like to point this out. So the values, which you could see in the task, will determine the number of lanes, and the determination of the lanes is just based on this table from the Eurocode 1 part 2, what I just prepared here. So the carriageway width W is just always between the curbs or the curbstones, and the number of lanes will just automatically calculated by the program based on this table. So at the moment we just have a default of 3 lanes, which means we just have a carriageway width of at least 9 meters. And then what is also just important, we just have here a subdivision of the overall width bridge deck. So we just have here notional lanes, and the lane according to the Eurocode always just have a width of 3 meters. And you can see also that we just have here residual areas and also footway or just a cycle track, so the pedestrian areas. Then we just go back to SSD again to the task, and then we're just making the input for our bridge. So we're defining it first, the value for curbstone left. And you can see immediately also in the graphic above the settings. Then we're just going to find the next value, so the curbstone right value. And you can see also in the graphic where the values are. So the border left minus 375 meters is just according to this red line. Then we just have to define the overall width bridge deck. So we're just starting with the deck left with a value of minus 4 meters, and then the deck right value with plus 4 meters. And you can see that we only have 1 lane. So by choosing the automatic subdivision into lanes according to the Eurocode 1991 part 2, 3 different sets of the lanes are just generated by the program. So at the moment you can see the center alignment, and there's only space for 1 lane, so 1 lane just have a width of 3 meters. Then we just have here also the most right alignment, and then we just have 2 lanes and also just residual area, which is just associated to the lane number 11. And then we also have here the most left alignment, and then also just the carriageway width. So the carriageway width, which is has the name lane number 0, is the overall width of the carriageway width, and the width of the footway and the cycle track is just given by the difference of the overall width and the carriageway width. And that's just important to understand that the footway and the cycle track is just the residual area of the lane number 0. Okay, then we'll just go further. We go to the next tab, load trains. And here we can just select the different types of the load trains just based on the design code. If we just press at the button at load trains, you just have here the different load trains according to the design code, and we're just taking the load model 1. So we're today in this SOFinar we're just interested at the global effects, and we also just have the possibility to take the other load models like the second or the third or the fourth one, and also just the fatigue loads. And if you just take the hook away here, you also just have the possibility to take the other load trains from the other design codes. And if we just switch to PowerPoint, I would like to show you what we're just going to do today. So we're just defining the load model number 1. So we just will define these load groups, so the vertical forces, so the tandem system load and the uniformly distributed load. We also just have to define the horizontal forces and also the forces for the pedestrian areas. So we're taking load model number 1, and we're taking the load model number 1 300 and 200 because we have 2 lanes, and for each of the load trains we also just have a table. So we just add them to our project. You can see immediately at the left hand side we have here a table for each of the load trains with all the necessarily values. So we just have a X load of 300 kilonewton according to the Eurocode. And these values just has to be considered very carefully, and you also just have the option to change this value if you want to, just with a double click on it. And you also just have the possibility to create a new load train. So if you just take user defined one, you can just change all of the settings. Then we just go to the next tab, the calculation tab. In this tab we can specify which inner forces we want to have in an envelope. For each of the inner forces, the lowercase number for maximum and minimum, which you can see here. So for each of the inner forces, the lowercase number for the maximum and minimum values are defined. And these lowercase numbers will be just aggregated on the base number, which we will define at the next tab. So you can see that we will get just the results for beams, but you also just have the possibility to go into the drop down menu and choose the other elements. So the other elements where you just would like to see the results of it. And so these elements which you can choose here just depends on the input which you have made before in SOFi Plus. So we're just going to create just a new envelope for the node in U set direction, and then we just have here also the possibility to change the settings, and this is just a very important point here. So we just have to tell the program how the load should be distributed in transversal direction, and we just have here also just a drop down menu, and you can choose between different settings. And if we just switch to PowerPoint again, I just prepared 2 graphics just to point out what are the difference of each of the settings. So if we just have a single girder system, we just have the possibility to choose the single girder system. So we just have here different settings, and if we just choose single girder system, means that an eccentrically placed loading generates directly a torsional moment, which you can see here. And the vertical forces and the torsional moment will be just applied to the single girder. If we just have a twin girder system, we just have the possibility to tell the program if the load distribution should be hinged or rigid. So we can directly address the main girders as the main structure elements and define how the load shall be distributed in transverse direction between the girders, and we can just choose hinges only, or we can just have also the second case, we can just choose the eccentric vertical force, which will just lead to a torsional moment, which is just the third case. And then we also just have the option for if we just have a shell system. So for slab system or hybrid systems, transverse influence lines on shell elements can be established, and you can define the numbers of load points in transverse direction. So you can just choose between if the transverse influence line should have 3 interpolation points or 5, 7 or 9, which you can see here. So if we just switch back to SSD, for our twin girder system, we're just going to take the multi-girder system rigid load distribution. Then we also just have here the option to define the vertical influence depth of the investigated node sequences. This will be just needed especially for spatial systems, but in our case 10 centimeters will be just enough, because the axis of our system will be just in the same level like our cross section. So we just can switch to the next tab, the load groups. So here we can just define the load groups according to the table 4.4 of the Eurocode number 1, which I just showed you in the PowerPoint presentation. And then we just have to define 3 load groups because of the different coefficients. So we just have to create 3 envelopes, and we're just starting with the Tandem system load according to load model number 1. So the name of it will be just envelope TS, so Tandem system. Then we just have here the possibility to give the envelope just a base load case number. We're just taking the default. Then we just have to choose the container, so the action. We are using the gr_t, which I just defined before in SOFi Plus in the load case manager. Then we just have to define a new case. So first of all, we just have to take our alignment. So we're not interested in the center alignment of the traffic because it's not unfavorable. So we're just looking at the most right and the most left alignment, and we're starting with right, and then we just have to choose the group. So that's just a filter, and we only want to have the single vertical loads. And then we just have to take here the load trains, which is defined in the second tab. And you can see immediately also the single vertical loads in the graphic above, so that we just have always just a control of the settings what we just made. Then we have here a table, and there you can just change the settings. So we just have here a column which is called fact, and this factor has nothing to do with the factors according to the action groups. It's just a general factor which you can just use. Then we have here the possibility to define a velocity, and according to this input the program will calculate a centrifugal force. Then we can just define here a value for the eccentricity, and here in this column we can just have the option to change the evaluation option, and we're just taking the default, but you also could just change the evaluation options if you want to. And then in the next column we just can change if the loading should be synchronic or not. So if we just have the hook here, the single loads will be just always synchronic. But according to the Eurocode, we just have to take the hook away. So the single loads don't have to be, so the axle load don't have to be synchronic. Then we just have here another 2 columns, and so the program will just place automatically the loading at the most unfavorable position inside the above region. And to achieve this, all selected points of the load train are just placed up to the 4 extremes of the influence lines. And the maximum value of this initial position is used for the detailed iteration. However, the region can be just input for special cases. And if you just need more details for these columns, just please look at the LR menu. Then we just have to define a second case, so for the most left alignment. And we just have to do the same, we're just using the same settings. And we also just have to take the hooks away. Then we're just creating a new load group, so for the uniformly distributed load. We're also just taking the default for the base load case number. And then we just have to take also the action group, which is just gr_u according to the Eurocode number 1. And we also just have to create new cases. And we are starting also with the most right alignment. And this time we are using the group GRU. So if we're just defining also the load trains, you can see above what load cases we are using. So we just have here a uniformly distributed load for the lane number 10 of 12 kilonewton per square meters. And then we just have here a load distribution of 6 kilonewton per square meters. And for the residual area, we just also have a distribution of 3 kilonewton per square meters. And this will be just the residual area is just associated to the lane number 11. Then we're just creating also just another case, so for the most left alignment, also just with the same settings. And then we just need a third case. We also just have to load the pedestrian area. So in the case number 1 and 2, you can see that the pedestrian areas are not loaded, and that's why we just have to create a new case. And in this case we're just taking the carriage widthway and we're taking the group GR3. And if we're just taking the load train, you can see immediately that only the pedestrian areas are loaded. And now we just have to create also just a combination. So in case number 1 and case number 2, the pedestrian areas are not loaded. And that's why we just have to create a combination, so that the program will take the most unfavorable load case of the combination from load case number 1 plus 3, or the combination of 2 plus 3. So we just have to create first of all a new combination, also just with a different type. And then we just have to create the cases, so the combination. So the program should search for the most unfavorable load case of the cases number 1 plus 3 or 2 or 3. And then we just have also to create a new load group for the horizontal loads according to the Eurocode number 1. And we also just need 2 cases. So we're starting with first of all with most right, and we also just have to take the other action, just other container, and also just the other group. So we're looking only for the horizontal loads, and if we're just taking the load trains, you can see immediately that we have here the uniformly distributed load plus the braking forces. So the horizontal forces will always act together with the uniformly distributed load. And then we just have to create the second case, so the most left. And now the lane number 20 just have a distribution of 12 kN per square meters plus the force, the horizontal force. Okay, then we just go further to the last tab, and here you can just determine what results you would like to see. So if you just take the default, you will just get the maximum of output, so it will be just a huge amount of results. So it's just necessary to think about what kind of results we would like to see. So which lines are just important for us, which results according to the element type is important. And we also just have the possibility to choose the number of elements we would like to see the results of it. So we're just taking the lane number 10 for example, we're choosing all elements, and we're just taking the element, so just a beam element which is just in the middle of our bridge. And then we can just finish the selection. It doesn't work. Just again. Okay, and yeah, so we just defined the traffic load in the traffic loader task, and now we just continue, and now we just go further to the results of the defined traffic load. Okay, now we're just finished, and if we just go look into the report browser, to the reports, you can see that we just have a lot of results, so 185 pages, and it first just starts with the program SOFiload, and here you can see that just to define load trains according to the design code. So you just have here the load train 300, and also just with the values according to the Eurocode, and also just we have here the load train 200, also just with the values. If we just go to graphics, we just have here the 3 envelopes which we just created in the traffic loader task. So we just starting with the Tandem system. We just have here the most right alignment, then the second case the most left alignment, and then we just have here the influence lines with the corresponding loads, which you can see here. Then we just have here the second envelope, so the uniformly distributed load, and we just created 3 cases. So it's always just good to control the input with the graphics. Then we just have here the 3 cases, so the uniformly distributed load, and we just have here the most right alignment, then the most left alignment, and then only the loading of the pedestrian areas. And we also just get here the influence lines and the corresponding load. And then we just have here the third envelope, so the horizontal forces, and also just the 2 cases. And we also just get here the influence lines, so for the bending moment my, with the corresponding loads. Okay, then we also just have the possibility to look at the maximum and minimum bending moment of each of the envelopes in WinGraph. So if we're just inserting a new task, first of all we just want to see the results at 1 girder. That's why we just have to use the boxes. So first of all we're just switching the view, then we're just using a box, so we're not interested in the results of the abutments, so only at the girder. Then we're just changing the view again, and then we're just using again a box. Okay, then we just have here also just a possibility to turn off the axis. So it edit, then axis, then show axis, and then we just can take here the hook away. Okay, so we're just interested in the bending moments my at the beam. And here you can see the bending moment of the load case number 1. And then we just have here the load cases of each of the envelopes, and we're just interested in the, as I just mentioned before, the bending moment my. And we're starting with the minimum, and now we just have the possibility to use 2 layers on one picture. So if we just press here the button new layer, we just have the possibility to create a new layer, and then we just have here the possibility to look in one picture at 2 results. So we just have here the minimum and the maximum bending moment my for the envelope TS. And then we're just creating just a second picture at one page, and if we just make a double click on picture, you can just change the drawing setups, and we're using 2 pictures on one page. Then we're just creating a new picture, and then we're just changing the load case. So you can see that we just have here the bending moment my, load case 109 and 10, and here the minimum and the maximum bending moment of the envelope TS, so the Tandem system. And then we have here the minimum and maximum bending moment my for the envelope UDL. Then we're just creating a new graphic. We're just deleting the picture number 2 because it's not necessary for our SOFinar. And then we're just going to look at the horizontal forces, so also the bending moments. So we're starting with the minimum my, and then the maximum bending moment my. And now you can see that we also just have here the comparison of the minimum and the maximum bending moment my from the envelope horizontal force or horizontal forces. Okay, so we just finished with the 4th SOFinar. I hope you just enjoyed it, and we would be just pleased if you just would join us at the next SOFinar. And yeah, thank you for your attention. Bye.